Welcome back. Half of our audience today got trained just yesterday by Zack Butcher and Adam Zicki. But today you have the great opportunity to dive deeper with Zack, founding engineer at Tetrate and close collaborator of NIST, on attribute-based access control for microservices-based applications using a service mesh. This is a NIST publication that you can find on NIST website by searching with the ID with a number 800-204-B. Zack, please take it.
Hey, thanks, Michaela. Thanks, everybody. I'm excited to be here and talking with y'all today. Go on to the next slide for me. So yeah, we're going to be diving into SP 800-204B, which I had the great pleasure to help co-author with Muli, who's here in the call and who will be given the next session as well. So we're going to dig into this. I do want to give a little bit of a different talk. We talked about this paper a little bit last year, and I'm actually really not going to talk a ton about the content that's in it. Sorry. What I am going to speak quite a bit about is a lot of the why. And then I'm going to call out maybe the 3 or 5, what I might call the load-bearing ideas from the SP. They're really the key points that I want y'all to take home. Go on to the next one for me. So a little bit about myself, just to set some context for you. I was one of the early folks to work on Istio. I was one of the early folks here to work on Tetrate as one of the founding engineers there. And then I write a whole bunch. I wrote or co-wrote Istio Up and Running. And then, like Michaela said, I collaborate with NIST around both these SPs as well as doing some collaborative research and development around next generation access control. Next one. All right, so I wanted to, again, I really want to kind of talk about the motivation behind the paper a little bit, and then the salient points that result from that. And so to really dig into that, I think it's important to understand the context for the paper itself. And really, I think I can sum up that context most effectively as these 2 problem statements, right? And we had these 2 dueling problems, right? So one of them is we're migrating to modern distributed architectures that make it hard to connect, manage, secure, and monitor our applications. And when I say a distributed architecture, I don't just mean containers in something like Kubernetes, but I mean that our infrastructure is distributed across our our legacy on-prem footprint, modern cloud footprints, often multiple clouds, because we have different teams that are consuming best and breed functionality, or we've had acquisitions, right? We have a variety of different compute within those clouds. It's not all just Kubernetes, for example, right? We have a lot of ECS or Lambda if we're in AWS, right? We have a lot of different runtimes. We have a lot of legacy VMs that are still in cloud too. And we need to figure out how we connect, manage, secure, and monitor our applications holistically across that entire set. At the same time, we have this problem with shrinking our perimeter that is, this kind of tenet of zero trust, right? This idea that we want to move the boundary of our application to the application instance itself. And these are 2 very challenging problems. Go to the next slide. So let me dig into the first one, and let's kind of explore this in some of the solutions here in a little bit more detail. Again, this is the context that this paper operates in. Next slide. So a service mesh is exactly a platform that is built to connect, monitor, manage, and secure services. And it's built to do this consistently. That's a key trait of the service mesh is centralized control that begets consistency. So if we go to the next slide, the service mesh does a whole bunch of different stuff. Just to give you a quick sample, I don't want to go in depth on what the service mesh is and all, but just a quick flavor, it facilitates the connection of applications by doing service discovery, by providing resiliency features, by doing load balancing. Next slide. It facilitates you managing traffic flow by giving you a point to do policy, not just security policy, but traffic policy routing as well. And we can do all this at L7, not at the connection level. Next one. The service mesh gives us tools to secure all of this by giving us a workload identity, which Kelsey talked about and did the hard way for us and showed how we can go about getting identities around. And then the service mesh lets us use those identities to do encryption in transit, with mutual TLS, so that we have both encryption as well as we have those identities to authenticate and authorize. Using those, then we can perform service-to-service authorization as well. And then next one, and then finally, we need to be able to understand everything that's happening, right? So we have all of these tools and features and capabilities to make traffic flow. Finally, we need to be able to understand what that traffic flow actually is, to be able to understand our system, to be able to assert system state, to be able to report back compliance to controls, for example, using these features. Next one. And again, those features are not new. I would argue, in fact, that if you've been building distributed systems for the past couple decades now, you've had to account for basically all of these in some way. Typically, that would happen via a library or similar. The key novelty of the service mesh is the way that it facilitates those with the sidecar. I'll talk about that in a second. And secondly, that it gives you this consistently with centralized control, with configuration-driven behavior, so that we can change it easily and rapidly in runtime. Next slide. So if we look at a service mesh, in a given deployment, there's going to be control plane. That is the service mesh that you interact with, that you push configuration, that goes and programs a whole bunch of sidecars, as well as ingress and egress proxies, to implement all those features that I just described above. And if we go to the next slide, within the context of 204B, the reference implementation of the service mesh that we use is Istio, the control plane. And Istio uses the open source project Envoy as the data plane, or as the proxy for the system. And so you'll hear me talk about Envoy, and really what you should hear is the thing that's handling the bits and bytes of request traffic. This is the thing that's presenting the identity that Kelsey talked about. This is the thing that's giving us all of those features that I just described, right? And additionally, it's not just beside all of our applications, but it's also, again, at ingress and egress as well, right? So if we go to the next slide. So that's a pretty, in short, the service mesh gives us a pretty good way to deal with this modern distributed architecture. It gives us a good set of primitives to work with. So that's great. Now, though, we have this second problem of shrinking our perimeter and removing implicit trust. Next slide. So how do we start to tackle that, right? There's a bunch of different things. This is not a complete list by any means, but, I say, for example, bind only to declared ports. What I really mean by this is, there's a variety of network-oriented things that we're going to need to do, to make sure that we're only exposing our service in the way that we intend to, right, from on our host, right? And that can include things like, hey, only accept traffic on, make sure the port 22 is not serving, SSH. Because you probably don't want that on a box that's, for example, exposed to the internet. And even though you maybe don't want to necessarily go expose all your hosts to the internet, that kind of mental model is the mental model that is valuable to work within when you're thinking about what zero trust means. So that's one side of it. But then, the other piece is, we need encryption everywhere, right? We can't have clear text, because then we don't have authenticity, and anybody could eavesdrop on that. We have problems of replay attacks potentially as well. So we need encryption in transit, certainly, as a baseline. But those are really the most two basic pieces. And then we need to start to authenticate and authorize every single request, not just every single connection, and not just at the edge and the DMZ and our API gateway, but every single hop throughout our entire system. Both the service that is communicating, both services that are communicating, need to be authenticated and authorized for that communication. But additionally, there needs to be some end user credential that is attached to every request that flows all the way through, so that we can authenticate and authorize a user's ability to access our resource at every hop along the way as well. And if we can do this, then we're making a pretty good effort on achieving zero trust. Next slide. And so if we look back at our service mesh, it has some features for us. Next slide. And those features largely take care of things like, hey, make sure you're doing simple stuff like only exposing the ports you intend. Make sure you're encrypting traffic, make sure you're encrypting traffic in transit. Make sure that you have a service identity that you can authenticate and authorize. The service mesh does all of that stuff for you. That's great. And we talk about a lot of that in SP 800-204A, the one previous in the series. And so in 204B, we really get to dig into that last bullet. Next slide. And so here we are, next slide again. And I'm going to take you through it backwards, because if anybody's read an academic paper, you always read it backwards. All the stuff at the beginning is mostly fluff. All the interesting stuff is at the very end. And so we'll take it from the interesting stuff. So next slide. So the first, and maybe this is the most important idea, maybe the second most important idea from the entire paper, which is this. Envoy, that sidecar that we've deployed beside all of our applications, and as the entry point, the ingress, and the exit point, the egress of our deployment, we have a policy enforcement point everywhere that's ubiquitous across our system. And because of the way that the service mesh works, forcing all traffic into and out of that Envoy, that sidecar, it has the opportunity to apply policy to every single request that it mediates, every single request that's going through it. In effect, it forms, what in the classic security literature we've called a reference monitor. This is huge, right? Because we have Envoy everywhere, and Envoy has extensibility points, we can use it to implement whatever policy we need. And today, the service mesh is focused primarily on traffic-oriented policy, as well as some limited security policies around service identity, service access, and service authorization, right? So this idea, Envoy is a universal policy enforcement point. You'll be able to use things like WebAssembly, custom Envoy extensions, Lua, and other capabilities to push your own policy into Envoy to be enforced by the mesh. And so there's extensibility there for you to plug into existing authorization systems, but Envoy gives us this substrate, this point to hook in and enforce policy. Next one. And one question here, actually, and I think this is maybe really, really interesting, is, somebody's asking, how do we actually, if we're encrypting everything, how are we applying policy per request? The answer is Envoy is what's encrypting it, not your application. So Envoy gets to see the clear text first and can operate on the request metadata, not the request payload itself. And then it's going to encrypt it and forward it along. Okay, so we have Envoy everywhere as our universal policy enforcement point. Now we need to stitch those individual sidecar, those individual proxies, instances together into a single coherent whole. That's what the service mesh control plane does. And when we do that, when we have this one control plane that's configuring how all of our policy enforcement points, all of our reference monitors behave, then we should call this the security kernel, right? This becomes effectively the heart of your system, of the security of your system. And you can offload a lot of security concerns here into this segment of your infrastructure that can be heavily audited, heavily controlled, that can have additional scrutiny applied to it. And you can focus efforts here because you're using it as the primitive that the rest of the platform is leveraging. And in that way, you can pull the security concerns down into this platform layer and remove your app developers needing to worry about them, quite so much of them, right? And so this is the second key idea, that the service mesh forms the security kernel for our system. And again, the security kernel, just like the reference monitor, is one of those classic ideas from security literature that we've talked about for the past more than 50 years now. And this is one of the reasons that for the folks at NIST that we're collaborating with, it's so exciting, right? That we get to realize this particular architectural pattern, which we know is good. We know this is how operating systems work. This is how a lot of our fundamental computing works today, the sound pattern. And we get to bring this forward. It's pretty exciting. Go on to the next slide for me. And then there's one other huge salient idea that I want to cement for y'all. And I'm cheating a little bit. This is a talk about 204B, but this idea we really dance around in 204B, but state most explicitly in 204A, which is that the service mesh, the key value that it brings is that it enables cross-cutting change. And because it gives us that central control point combined with consistency across the fleet, because we have that Envoy everywhere. So we have centralized control with distributed enforcement. The enforcement is distributed to all the envoys beside every application. So they're in the same perimeter as the application, but we have that central point controlling it, right? What this allows us to do is have focused small teams within our organization that are managing policy for everybody. And they have the tools to actually go and enact that policy, not just ask very nicely for the entire organization to do it, right? They can go and actually enforce it, enact it in practice, and prove that that control is in place, right? This is a huge force multiplier. And so these three things taken together, I would argue, are the true superpower of the service mesh. We have Envoy ubiquitously that allows us to implement policy. We have the control plane that gives us this place that we can centralize the control and that we can focus our security concerns into this kernel, the service mesh itself. And then using that kernel, we have the capability of enacting cross-cutting change across the organization and doing things that traditionally we might need to go to every individual application to get to change, we can do centrally in the platform. It's incredibly powerful. Next slide. So what's the rest of 204B? And if I were going to summarize it in one sentence, it would be a whole bunch of sensible defaults that you should do, right? And the goal for us in general with these SPs is not to create novel standards here, but really is to take well understood and known best practices and talk about how they apply to this new world. Next slide. So if we look in a single, if I were going to summarize, 204B into a single slide, I would list the recommendations that we make roughly like this, right? Which is the APE recommendations are really amount to have authorization policies that are very descriptive and actually author them in your system, please. The end user authentication and end user authorization recommendations are very similar. Be able to have end user credentials everywhere. Be able to extract them with the service mesh and authenticate them with the service mesh. And please author a policy that mandates that every service requires an end user credential. And by the way, you need to have metrics throughout the entire system that's reporting that, yes, there are end user credentials. Yes, I am authenticating them or not, and what those results are. The end user authorization SR1 there also talks about the fact that if we are going to be communicating with external systems to for example, do authorization of end user access or to authenticate end user credentials, that system, the communication with it should be secured, and probably you should actually use the service mesh to secure that communication itself. And if you do that, then in fact, that's a better default because you have a same consistent security substrate across the fleet, right? You don't want to have to manage IAM separately and then have everything else be in the mesh. Use the mesh just to help secure your IAM system itself. The service authentication and service authorization recommendations are basically the equivalent of the user ones, but for services, which is please have policies in place, make sure they're descriptive, and then actually author them, right? It's not enough just to say we can do it. Too many organizations go, great, we turned on MTLS, we have the ability to do authorization policy, cool. And then they don't mandate that they're actually done, right? The AHLC, which are about the application running in kind of container security, right? Basically amounts to, hey, do sensible things with containers, right? Make sure they don't have privileged access. Make sure they don't have host mounts. Make sure they're locked down and don't have privileged access is the general key. And then finally, the initial service mesh configuration recommendations here at the bottom, where we make two, effectively saying, hey, look, your mesh PKI, please integrate it with your existing PKI. Don't have a separate PKI only for your service mesh. It can be hard to manage. And then finally, for communication between the service mesh and your platform, make sure that's secured. Istio does this out of the box, for example. So that is, in a nutshell, the entire paper. We discuss at length, and what I did not talk about is how ABAC, we argue, is the type of system that you should be using to do this authorization throughout. So we say, hey, you should be doing authorization everywhere. We make the argument that ABAC, attribute-based access control, is the best way to do that. And with that, it is time for questions. And so let me go through, or Josh, if you have something you want to pick out, please go for it.
Sure. Yeah, I got one right here. The question is Envoy bound to Kubernetes? Can one use it separately from Docker, a Docker Kubernetes environment?
Yeah, totally. And in fact, actually, the initial deployment of Envoy inside of Lyft was on a bunch of EC2 VMs to be their ingress gateway, basically, right? And so those were run not containerized at all. We additionally, Tetrate, I work with folks regularly who push the service mesh into legacy environments. And so we run Envoys on VMs and on bare metal environments all the time. And so no, Envoy is not in any way bound to Kubernetes, although you hear a lot of service mesh talk focus on Kubernetes for sure.
Awesome. What are some examples and extent of impact in terms of refactoring or redesigning of legacy applications if adopting a service mesh / zero trust architecture-like approach? Does the sidecar proxy approach fully mitigate this?
So the sidecar proxy is going to give you a lot of kind of tools to aid your transition and modernization. It's going to facilitate, for example, secure connectivity, the service discovery, and all of those pieces, right? So it's an important, in our experience, it has been a very valuable tool for being able to, for example, implement the strangler pattern to migrate traffic from a monolith into a set of microservices.
Another one is, would PBAC be better than ABAC for Auth-Z?
So PBAC, I'm not sure offhand what it is. Do you know actually? No, okay.
Know what PBAC is.
So the short answer is that, from an access control perspective, ABAC is equally powerful to any access control system that we know about, right? And as far as we're aware, any other access control system could be modeled in an ABAC system, right? Now, when we talk about in 204B, when we talk about ABAC specifically, we actually talk about a very particular flavor of ABAC, which Josh and David and the team at NIST have been working on, and we collaborate with, called Next Generation Access Control. It is not like your typical XACML-based ABAC system. It's very different. And I believe we'll have some talks about that from both Josh and Ignacy a little bit later today.
Yeah. And just so to clarify, PBAC is policy-based access control.
Yeah.
Go
for it, sorry.
I'm just checking if we have time for another one.
Yeah, let me, if you don't mind, I'll take one more. I think we have 1 minute left, which is there, hey, this 204B allow for eBPF instead of Envoy or with Envoy? Yeah, look, 204B uses Istio and Envoy as the reference implementation, but the set of recommendations we make are not tied to the specific implementation that is Envoy. And in general, eBPF you should view as an accelerator, just like a TLS offload card that you could install, or specialized instructions that might exist on some CPUs, right? All of them are tools that we have to accelerate or make it take less time for us to do whatever processing we need on the data plane. eBPF is just one other tool, and if it turns out to be compelling from a performance perspective and from a behavior perspective, you'll see it get incorporated into the open source service meshes that exist.
Excellent. I think that's all the time we have.